So let's see, like everyone's done. Okay, so let's say, for example, we wanted to convert f of x equals 2 times x minus 3 squared minus 4 to the general form. Let's say to f of x equals ax squared plus bx plus c form. Okay, so we don't want to take it to standard form and move it to general form. Okay, now this way is actually not too bad, because f of x equals 2 times x minus 3 squared minus 4. Yep, all we have to do is separate that. That's just 2 times x minus 3 times x minus 3 minus 4. Okay, so if we go ahead and do the FOIL method there, we have 2 times x squared. Yep, minus 3x. We could have just made it minus 6, but I'll go through the actual steps. Yep, plus 9. And don't forget your minus 4 on the end. Okay, so you 2 times x squared minus 6x plus 9 minus 4.
2x squared.
Yep, so now all we have to do is distribute our 2x squared minus 12x plus 18, and don't forget your minus 4 in the end. Okay, and once you combine those two, you're pretty much done. 2x squared minus 12x plus 14. Okay, so that's just the converted version of where we started. Now going the other way is a little trickier. Okay, so I'll leave that up for a few seconds. Leave it up for a few more seconds. Okay, so now we want to rewrite f of x equals 4x squared minus 16x plus 17 in standard form. Now remember, standard form is just f of x equals a times x minus h squared plus k.
Do we do it by finding the vertex first?
You can. There's a couple of different ways to do it. So you can find the vertex, but a lot of times it will, because once you find the vertex, if it's a fraction and you're plugging in a fraction into that one, it can get a little bit tricky. Now this way is a little bit easier because you're going to simplify it some. So your first step, you're going to find the greatest common factor in the first two terms, or factor out the GCF. So factor out the greatest common factor from the first two terms. Okay, so that means if we have our f of x equals 4x squared minus 16x plus 17, we're going to factor a 4 out of both of those. Well, it's just a greatest common coefficient. Let me click, because greatest common factor would be 4x, and that's not what we want to do. Greatest common constant from the first two terms. That's a little clearer. Don't want to confuse anyone. There we go. Okay, so now if we want to factor out the greatest constant, that would just factor out a 4, which would leave us x squared minus 4x.
Can we factor x?
You can, but you want to leave it like that. Because once you leave it like that, you can just use the completing the square. So it makes it a little easier. Okay, so next you want to complete the square of what's in here. Okay, so if you remember, completing the square is b divided by 2a squared. So for x squared minus 4x, just that part, a is equal to 1, our b is equal to negative 4. Okay, so that's negative 4 divided by 2 times 1, so that's negative 4 divided by 2 squared. Okay, so remember that's just negative 2 squared. You want to remember that value, which is 4. Okay. Now remember, we're just completing the square, so we're just going to add and subtract that value. We're not going to do it on both sides of the equal sign or anything like that. So this value you just add and subtract. Okay. So that means we end up with 4 times x squared minus 4x plus 4 minus 4. Plus 17. Might as well put the f of x in front here. There we go. Okay. Now here, what we're going to do, and this is kind of the tricky part, we're going to separate these two. So we have 4 times every term in here. We're going to leave these 3 together, and we're just going to separate that one. But remember, 4 is times all of that. So you're going to have 4 times all of that, and 4 times that minus 4. Does that make sense? Okay. Okay, so you have 4 times x squared minus 4x plus 4 minus 4 times 4. Plus that's 17 that's already there. Okay, and the reason we brought out these 3 is because we now have our perfect square trinomial. Okay, so that's going to equal 4. Remember, our completing the square was 4, so this just becomes, oh, where did I mess up? Yep, x minus 4, x minus 2 squared. There we go. because you have to remember that value. So that goes in here. Minus 16 plus 17. Yep. So any questions on that step? All right, so that will give us 4 times x minus 2 squared. And once we combine these two, we just have plus 1. All right, so any questions on that one? All right. So converting it to standard form, to general form is a little easier than converting it to standard form, but it's just a couple more steps. All right, leave that up for a few more seconds. Like everyone's done writing. Okay. So now we're actually going to come up with the equation for that parabola. And just given what they have right here. So there are really 2 methods you can use for this one. Okay, this is method 1. And that's when you're going to use your x and y intercepts. Okay. And we can do that because we can clearly see what the x and y intercepts are. Excuse me. Okay, so the first thing you want to do is remember that if you have ax squared plus bx plus c, you can actually rewrite that as a times x minus h squared plus k. And really, since you have a quadratic formula, you know it's quadratic, it's a parabola, so you know it's quadratic, you can rewrite that as a times x plus or minus some value, we'll call that some value number 1. Let me put that underneath it, so I'm not trying to squeeze everything in one spot. Okay, so we can also make that equal to a x plus or minus some value times x plus or minus some value, we'll call that some value number 2. So this, even though it may come out to be complex or whatever the case may be, we can always factor it. So what this is saying is that just like we did when we converted it, we factored out the a value, we can factor that into 2 factors. Okay, so what we're going to do here, since we're using the x and y intercepts, we're going to use that value. Okay, so this is where the second step comes in. You want to find your x and y intercept points. So if you notice, your x-intercepts are -2, 0, and 1, 0. So we know just by looking at it that when x is equal to -2 or x is equal to 1, both of those will make y equals 0. So y equals 0 when x equals -2 and x equals 1. Okay. So since we're using that one, we have y equals a. We don't know what a is yet. Okay. This is x, and this is where you have to really pay attention. This is x plus 2, even though that's a -2 there. And I'll show you why in a second. And instead of plus 1, this would be x minus 1. Because remember, if you plug in x equals 1, that y has to equal 0. So 1 minus 1 would give us 0, which would make everything 0. And if you plug in -2, -2 plus 2 is 0, which would make everything 0. So you got to pay attention to change the sign over once you plug it in. Does that make sense? Okay. All right, so we have that. So we have our value here. So the next thing we want to do is solve for a. Okay, so that's where we use our y-intercept. So use y-intercept, which is 0, -2. To solve for a. Okay. Now our y-intercept just tells us that when x is equal to 0, y is equal to -2. X equals 0, y equals -2. So we take this, we replace x with 0 and y with -2. Okay. So that just means y equals a x plus 2 x minus 1. That just becomes, -2 equals a, not x plus 2, but 0 plus 2, and 0 minus 1. Okay, so we knew just from that y-intercept that when x is equal to 0, then that y has to equal that, which means once we get it like this, we can just solve for it. Okay, so let me move that up a little bit. Okay, so this is -2. Equals a times 2 times -1. Or -2 equals -2a. Or a equals 1. Okay, so we know that y is equal to 1, which you don't really have to put the 1 there if it's there. X minus 1. Okay. So once you get there, you just go ahead and use the FOIL method. So you have x squared plus x minus 2. Okay, so that's the formula for that parabola. All right, any questions on that one? Okay, so that's just the first method. That's if you know for a fact what your x-intercept and y-intercepts are. And normally what they'll have on the graph, you'll see those highlighted spots kind of telling you that you can use them. But you have some, where your intercepts aren't as clear. Okay, so what if we wanted to determine the equation for this one? Here, you don't know if your intercept is on x equals -0.5, -0.6, -0.55. You have really no idea what it is. And this is where you would use the second method. Use any point and the vertex. Okay. Kind of clean that up a little. There we go. Like I said, you'd use this one if you can't look at it and tell exactly what your x and y intercepts are. Okay. So once again, your first step, you're going to remember your basic forms. So you know your ax squared plus bx plus c. You have a standard form of a x minus h squared plus k. And we also have our factored form of a x plus or minus some value and x plus or minus some value. Okay. But since we're not using the x and y intercepts, we use that method because we have a clear idea of what our vertex is. That's right on that spot. Okay, so we don't have to guess for that one. Okay. So for our second step, we're going to notice that our vertex is the point -3, 4. Okay? And we know that when it's in this form, our vertex is just hk. That means our h is -3, and our k is 4. Okay? So just that simple, we figured out what the h and the k is. We can just go ahead and plug it in. Okay? So that means that y equals a times x minus -3 squared plus 4.
It's not a 3 for the h because the formula is x minus h, but it can be 3.
Yep, so it's just going to be 3.
Yeah, but you write -3.
Oh, I know, just to avoid skipping steps.
Okay.
That's all. Okay, so that means we have y equals a times x plus 3 squared plus 4. Okay, so we have a good chunk of it already. Okay, so just like before, our third step is we have to solve for a. Okay, now before we use the y-intercept, but we can't really do that here. So now we can pick any point at all for our x and y. So if you look, you'll see you can tell exactly where that one is. You know that's a -2, 2. Or you could have picked -4, 2, but you can pick -2, 2. Okay. So since the x-intercepts are not clear, use any point to solve for a. Like I said, the x-intercepts just kind of make it easy because you're dealing with zeros and stuff disappears and cancels out. So when you can't use the x-intercepts, you can use any point. So for this one, we'll use -2, 2. And I don't want to have a bunch of parentheses laying around. Use -2, 2. That is a point on the graph.